Let's take a look at Newton's first law of motion. So Newton's first law of motion is also known as law of inertia. If you look at the statement, what it says that an object in motion will remain in motion and an object at rest will remain at rest unless, that's a condition, acted upon by a net external force. Now this is the classic version of Newton's first law of motion, what it says. Another way that we can look at how Newton's first law of motion describes the motion is tells us that an object's velocity will be constant if there is no net force acting on it. Now this brings up the word net force. So let's go ahead and define what is net force. So net force is the sum of all the forces acting on an object. And if we put it in the symbol, it's capital F for force and the subscript net, or we can put it as summation sign F, which means the summation sign means sum. Let's take a look at an example. Let's say we have a force to the right and left. They're both equal and the net force is equal to 0. We have another example where we have 20 newtons to the right and 15 newtons to the left. In this case, our net force is 5 newtons right. And when to find the net force, we'll look at the left and right and up and down directions. We see the up and down direction, the forces are balanced. And on the right and left, we have a net force, which is 8 newtons to the left. Now let's look at this example where we can understand and break it down and what it means for an object to have a net force equal to 0. So let's say we have this object which has a net force 0. If the net force is equal to 0, the object is said to be in equilibrium. That's a big word. What it means is that the forces are balanced. They're either balanced in the horizontal or the vertical directions. And it also means that the forces add up to equal 0. Now let's return to Newton's first law, which says that an object velocity is constant if F net is equal to 0. That's what first law tells us. So if velocity is constant, we know it from kinematics that acceleration is going to be equal to 0, which means that in the acceleration is 0, then the net force is also equal to 0. There are different ways to say and express it, but mainly we're looking at velocity being constant, acceleration is 0, and the net force is also equal to 0. So the object is in equilibrium, or we can say that the forces are balanced. Let's take a look at example 1. We have two forces at a book on a table. Let's say we have gravitational force 6 newtons down, normal force from the table 6 newtons in the upward direction. You can see that the net force is equal to 0, and also we know that the book is sitting on the table and it's at rest. So let's try to understand what is going on in this scenario too. So the net force is 0, which means that it is in equilibrium. And the first law tells us that velocity must be constant. And as you know that the book is at rest on the table, so it means that the book will remain on the table as long as there's some force applied on this book. And it will remain at rest. Let's take a look at another example too. Let's say we have a hockey puck sliding on the ice. Again, we have two forces, gravitational force and the normal force from the surface on which it is sliding. And we know that the puck is moving, and let's say it's moving fast. But again, you still see that it is in equilibrium. The forces are balanced, or the net force is equal to 0, which means that the velocity is constant and it is going to remain moving unless there is an external force applied on it according to the first law. So the forces are balanced and the puck is still moving, which this situation has a special name called translational equilibrium. Now, what does translational equilibrium mean? What it means is that the object is in equilibrium and is moving. So the two big words that we can get from it is equilibrium and moving. Now let's say you're standing in a subway car, you are in translational equilibrium. If the car suddenly stops, your velocity will be constant according to first law until an external force acts on you. So hopefully you're holding on to something so the pole can help you stop moving, but if you're not holding on to something, you will continue to move forward until you're stopped by a person or a wall. Now this concept is called inertia. Inertia is defined as the tendency of an object to resist changes in its velocity. The word inertia is basically proportional to the mass of an object. So let's understand what it means. Let's say we have a mouse and we have an elephant. Now we know that mouse has less mass, elephant has more mass, which means that mouse has less inertia and is easier to change the velocity. Whereas the elephant has more mass, means more inertia, and it will require more resistance to change its velocity.